So, Ramna, can I start?
Yeah.
1 minute. So, good afternoon, everyone. Is my voice audible, sir? Hello?
Yeah, audible.
Yes, sir. Okay. Good afternoon, everyone. A warm welcome to everyone. I'm Divya, Zoo Education Officer.
Divya,
Yes, ma'am.
sorry to this thing, but you are still not started. You're still not live.
Okay. It
Yeah,
will
now
be.
okay, fine.
Yes, ma'am.
Go ahead, go ahead.
Yes, ma'am.
There's a lag.
Yes, ma'am. 1 minute lag it will be. Shall I start now, ma'am?
Yes, please go ahead.
Yes, ma'am. So, a very good afternoon, everyone. A warm welcome to everyone joined in today's webinar session. I'm Divya, Zoo Education Officer. Gives me immense pleasure to welcome you all who all joined in today's webinar session conducted on the occasion of International Day for Preservation of Ozone Layer, 16 September 2022. I also heartily welcome Dr. Nandini Saleri, IFS Curator, IGZP Visakhapatnam, and all other speakers. The preservation of the ozone layer is so important for us that a day is dedicated to create awareness and educate the people on ozone. Joined us today to speak on ozone is Shri Honorable Professor Raju Salmon Sir, Department of Environmental Sciences at Andhra University. Shri S. Bhanu Kumar, Professor of Meteorology, Honorable Director, Department of Yoga and Consciousness, Andhra University, Visakhapatnam. Ms. Mahima T, Senior Environmental Engineer from Central Pollution Control Board of India. A brief introduction of Sir Honorable Professor Raju Salmon Sir. Sir is right now working in Department of Environmental Sciences in Andhra University. Uh, Sir has completed his PhD at the age of 27 years. He worked as Scientist Pool Officer CSIR in Government of India. He also served as Head and Chairman Board of Studies in the Department of Environmental Sciences in Andhra University. He is currently a Chairman Board of Studies of Microbiology and member of Academic Senate of Andhra University. Now I request Solomon sir to please present your slide, sir. So kindly please present your slide, sir.
Yeah. Is it visible?
Yes, sir, it is visible. You can please begin your talk, sir.
Okay. Thank you very much for welcoming me and also for introducing me to this audience on this particular day, International Ozone Day. For this year, the theme is, as already know, so it's not local cooperation or national cooperation or international cooperation, global cooperation. All humanity should cooperate with each other in order to protect life on this planet Earth. Why? Because this is the only planet where we find life, the existence of life. So the World Ozone Day or International Ozone Day, so is celebrated every year on 16th September, and this day is celebrated in many areas, and sometimes it is observed, simply observed, to spread awareness among people of all classes of the society about the importance of ozone layer and what happens if ozone layer is depleted, where it occurs in this atmosphere and all the things, and also to find possible solutions to preserve ozone layer in the stratosphere. On this day, people usually hold seminars and talks, nowadays webinars on this ozone layer from all over the world. So now today, this zoo park is organizing this event, and I appreciate that for this particular purpose. And educators teach students about the importance and benefits of ozone layer. So these are the things generally which we generally talk in general public. So before we actually go what is ozone and all the things, first we should know what is sunlight. So here, first we should know about all these things. Solar radiation is made up of different types of radiation. So first one is infrared radiation, second one is visible radiation, and third one is ultraviolet radiation, and also other types of radiation are there beyond visible wavelength spectrum. But out of these things, ultraviolet radiation, here we are concerned about this ultraviolet radiation in connection with this ozone layer. So now visible spectrum, from violet to red. Ultraviolet means it's more than violet, and infrared means less than red. So within this, we can see that different colors within this visible spectrum. But ultraviolet and beyond, and those things are very much concerned in, regarding this ozone layer. So what is the what are the causes of this ultraviolet radiation to life in general and human beings in particular? So UVA. So there are different types of UV radiation, UVA, UVB, UVC. UVA is close to what you call the violet visible wavelength spectrum, UVA. But this UVA radiation is not absorbed by ozone layer. So it directly strikes through the atmosphere, it strikes this Earth at ecosphere level, and this radiation easily passes through the atmosphere, reaching the entire Earth surface. It causes premature skin aging and skin cancer and eye and immune system problems. So since ozone is not absorbing this, it directly strike this planet through the atmosphere. UVB, it's when compared to UVB, it has a short wavelength. It is mostly absorbed by ozone layer, but not absolutely. But still, considerable amount of this UVB radiation strikes this planet Earth. It has greater difficulty passing through the atmosphere, but this wavelength reaches the equatorial zone more quickly than at high latitudes. And the causes for this UVB radiation health impacts are sunburn, darkening and thickening of the outer layer of the skin, melanoma, and different types of skin cancer, in addition to eye and immune system problems. So UVA and UVB both strike this planet Earth, especially at troposphere level, and generally UVA directly, but UVB is to some extent is absorbed by ozone layer, ozone that is present in the stratosphere. UVC, it is the shortest wavelength within UV spectrum, but it doesn't pass through the atmosphere because it is completely absorbed by ozone layer in the stratosphere. So UVC is totally absorbed, prevented from penetration into the atmosphere where humanity or life exists. So what are its effects? It is germicidal, and it causes genetic mutation, germ killing, and it causes DNA damage, and DNA cannot be repaired again, and genetic aberrations, and so many other problems. So that means germicidal. So life threatening, life killing. So that's why UVC is very dangerous when compared to UVA and UVB wavelength spectrum. So that's why in this connection, UVC, we are very much concerned about having ozone layer intact in the stratosphere. So Earth's atmosphere, if you classify Earth's atmosphere into different things, there is only one atmosphere for the sake of convenience and understanding, and also so the atmospheric chemistry also changes in different layers accordingly. This classification is there. Troposphere, it is the lowest layer of the atmosphere. So here in this troposphere, atmospheric turbulence is very common, and when you fly in a plane, you also experience this atmospheric turbulence. Flights usually experience turbulence in this troposphere. And the stratosphere, this is the next layer above troposphere. It is completely free of clouds and other forms of weather. It lacks air turbulence and is quite advantageous for long distance flights. And many flights fly in the stratosphere, lowest layer of the stratosphere, or within in the layer between in the tropopause between troposphere and stratosphere. So flights usually fly in that area, but since there is no turbulence, in the stratosphere, long distance flights fly at that level. But since they fly at that level, they also release vertical flight exhaust and so many pollutants, out of which the most prominent one is NOx, which destroys ozone. So that is the main problem with long distance flights which fly in this stratosphere, especially the fly only in the lowest layer of the stratosphere. And that is followed by mesosphere. So in this layer, meteors burn up while entering the lower layers of the atmosphere. So mesosphere has its own role in maintaining this atmosphere. Thermosphere, that is followed by thermosphere, the layer above mesosphere, where temperature rises even beyond 1000 degrees C. And I'm not going to explain everything. Next one is ionosphere. This is above thermosphere. The layer above thermosphere, it is ionized by solar radiation. That's why it is ionosphere. The short wavelengths in this layer are used by satellites for imaging the Earth. This layer is important for radio, television, and satellite communications. So the ionosphere also has certain advantages for human beings here. Exosphere, so that is the last, so the topmost layer of the atmosphere. Exosphere, it is the highest layer or upper limit of the atmosphere. Many satellites orbit this Earth in this layer. So different vertical spheres have different purposes, and they also have their own unique role in maintaining Earth's atmosphere for the survivability of life in general. What is ozone? Ozone means smell. That it has its own Greek word from ozone. It was first discovered in the year 1839 by a German scientist by name Christian Friedrich Schonbein. It is a pale blue, relatively unstable molecule made up of 3 oxygen atoms and has the formula O3. Ozone life, how life is connected to ozone. So this is very important. Why we need to take measures for the vertical, for the maintenance of this ozone layer and all. 1 billion years ago, early aquatic organisms, blue-green algae, used energy from the sun to split molecules of water and CO2 and recombine them into organic compounds and molecular oxygen. So that's how we explain photosynthesis. So some photosynthetically created oxygen by this blue-green algae about 1 billion years ago, combined with organic carbon to recreate carbon dioxide molecules. That is another one. The remaining oxygen, so some oxygen that is released from photosynthetic activity is used for what you call is combined with organic carbon to recreate carbon dioxide molecules. That is one aspect. And the remaining oxygen gradually accumulated in the atmosphere. When it gradually accumulated, so CO2 levels also gradually decreased because photosynthetic activity started to take place, and therefore CO2 is being fixed in life, in biomass, in the form of biomass. So that's why CO2 levels, concentrations gradually decrease and oxygen levels gradually increase. It got accumulated. High in the atmosphere, some oxygen, molecular oxygen, absorbed energy from the sun's ultraviolet rays and split to form single oxygen atoms. These atoms combined with remaining oxygen molecules to form O3 molecules, which are very effective at absorbing UV rays. So this is how ozone layer was formed in the stratosphere. So this is the genesis of this ozone formation. So the thing has, vertical has linked to blue-green algae, which produce oxygen, and that oxygen finally got converted into ozone. The amount of ozone required to shield this planet Earth from biologically lethal UV radiation to have been in existence 600 million years ago. At this time, at this particular period, the oxygen level was approximately only 10% of its present atmospheric concentration. Just imagine the present atmospheric concentration 21% oxygen. Prior to this period, life was restricted to the ocean only because there was no life on land. So then life was restricted to the ocean where blue-green algae, unicellular organisms and other things were there. Whatever organism which has chlorophyll, it started to vertical fix atmospheric carbon dioxide with sunlight. And in that process, oxygen was released as a byproduct. So the presence of ozone thereafter enabled organisms to develop and live on the land. So because UV was directly coming hitting the planet Earth, so because there was no ozone at that time. So since ozone gradually formed over a period of time, so then life got evolved and gradually life, what you call, extended to land. So this is how evolution took place of organisms took place not only in the ocean but also on land, because ozone acted as a protective layer in the stratosphere. So without ozone, there is no question of life on land. That is the point here. Balanced state of ozone. In unpolluted atmosphere, there is always a balance between the amount of ozone being produced and the amount of ozone being destroyed. So the total concentration of ozone remains relatively constant. Then there is absolutely no problem. The problem is only when atmosphere is polluted. Ground level ozone produced due to pollution is called bad ozone. But if the same ozone is there at ground level, that is detrimental for life. But the same ozone, if it is there in the stratosphere, that absorbs UV light, that protects life, that enables life, that sustains life, not only in the present times, but also in future times, or as long as ozone is there intact in the stratosphere. Stratosphere level ozone is called good ozone. The amounts of good and bad ozone in the atmosphere depend on a balance between processes that create ozone and the processes that destroy ozone. That is the thing. So that is the balance. That balance is required. An upset in the ozone balance shows serious consequences for life on this planet. Chemicals destroying ozone, industrial and natural processes, volcanic injections, aircraft exhausts, in the troposphere and also in the stratosphere. Methane, CFCs, and nitrous oxide and water injected into the stratosphere through covering tropical cumulus clouds. These compounds are broken down by UV light in the stratosphere, and the byproducts play an active role in the destruction of ozone. That's why we are concerned about the use of all these chemicals, maybe in urbanization or industrialization or in food sector or any other sector where human activity is taking place. So that's why we are very much concerned about the chemicals, so which destroy this ozone. And chlorofluorocarbons and hydrochlorofluorocarbons. They are fully or partly halogenated hydrocarbons which contain carbon, hydrogen, chlorine, and fluorine, produced as volatile derivatives of methane, ethane, and propane. They are commonly called by DuPont, known by DuPont brand name Freon. Many CFCs, chlorofluorocarbons, are widely used as refrigerants, solvents, foam blowing agents, and aerosol propellants. The manufacture of these compounds are phased out under Montreal Protocol in 1987. Uh, all countries which are party to that Montreal Protocol, they took certain measures to reduce the use of these chemicals, CFCs. The CFCs are being replaced with HCFCs and also HFCS, hydrochlorofluorocarbons and hydrofluorocarbons. Hydrochlorofluorocarbons are less stable when CFCs are more stable. So that's why hydrochlorofluorocarbons are used in place of CFCs, because they are less stable and break down before reaching the ozone layer, but still a significant fraction do break down in the stratosphere and contribute to more chlorine buildup, destroying ozone. And next, after HCFCs, still they are able to destroy ozone or reaching the ozone layer. Again, HCFCs are replaced by HFCs. So hydrofluorocarbons, which lack chlorine, they have a very shorter lifetime when compared to HCFCs in the lower atmosphere, and hence the possibility to destroy ozone layer is minimal. So that is theory, but practically we do not know. Alternatives to HFCs are used in different sectors in the present times are propane, isobutane, and ammonia, and carbon dioxide. But here, what cost effectiveness, economics also matter to use all these chemicals in place of CFCs or HCFCs or HFCs. And what is ozone hole? It is really a reduction in concentrations of ozone high above the earth in the stratosphere. Ozone hole is defined geographically as the area wherein the total ozone amount is less than 220 Dobson units. So this is how ozone hole is defined. But technically, there is no ozone hole. But it is a region of exceptionally depleted ozone in the stratosphere over the Antarctic that happens at the beginning of southern hemisphere spring in the Antarctic region during August and October, August to September, October. That is the southern hemisphere. So this is the area where ozone hole is very prominent. So that means that the depletion of ozone is very prominent when compared to the depletion of ozone layer in the Arctic region, in the northern hemisphere. So the decrease in the ozone layer was predicted in the early 80s to be roughly 7% over a 60-year period. The sudden disappearance of 50% of the ozone layer in a localized area of Antarctica created a stir. That's why in 1987 there was Montreal Protocol in order to take measures to reduce the chemicals which are harmful, what you call to destroy this ozone layer. A localized depletion was observed during the Arctic spring over the North Pole. But there is no concern about this smaller ozone hole in the northern pole, but only in the southern hemisphere, that is in the our Antarctic region. Antarctic hole is a warning that if conditions become more Antarctic, cooler stratospheric temperatures, more stratospheric clouds, more active chlorine, then global ozone will decrease at a much greater pace. So we should take measures to close this ozone, to close this ozone hole. So that is why Montreal Protocol came into place, and all participating countries, all parties of this UN or countries of this UN took all possible measures in order to see that there is a reduction in the use of chemicals which contribute to this destruction of this ozone layer in the stratosphere. So you can see this whole extent about the southern hemisphere in our Antarctic uh, region from 79 to 2021. So from up to 2021. So this is only during winter. During spring we see there is hole, and again in summer there won't be hole. A hole is almost closed. So this is not consistently there won't be a hole. Seasonally there is a vertical. That means it is meteorological conditions decide whether to vertical to create a hole or to close the hole. The prevailing meteorological conditions in that particular season are contributing factors for the vertical, for the creation of this ozone, or for the expansion of the ozone hole, or for the closing of the ozone hole. Today, the ozone hole still exists, forming every year over Antarctica in the spring season during August and October. This is the time. It closes up again over the summer. Why? Because as stratospheric air from lower latitudes mixed up. So in spring season, temperature is very vertical, lower temperatures, cool temperature, there is no question of mixing of air. So that's why ozone hole is very clear there during a vertical spring season. But in summer season, because of the mixing of stratospheric air, patching it up, the hole is patched up, patching it up until the following spring, when the cycle begins again in the next vertical, uh, in the next season. Scientists state that there is evidence that it is starting to disappear and recover more or less as expected. The ozone layer is expected to return to pre-1980 levels around the middle of this century. Healing is slow because of the long lifespan of ozone depleting molecules. That is the point. Some ozone depleting molecules or chemicals persist in the atmosphere for about 50 to 150 years before decaying. That is a problem. Ozone hole is a completely different phenomenon to global warming, but there are links between them. The ozone hole is caused by ozone depleting chemicals in the atmosphere, which are produced by different human activities. One link is CFCs. This is a greenhouse gas. So that's how we connect this global warming to ozone hole. The serious threat posed by ozone depletion, it rises in skin cancer, cataracts in humans, harm to plant growth, agricultural crops and animals, and also to causes reproductive problems in fish, crabs, frogs, phytoplanktons, which form the basis of marine food chain. So that means every life, whether minor, so what you call minute life or micro life or macro life, every organism, every species gets affected if there is a serious threat to ozone layer in the stratosphere. The creation of the ozone hole showed how rapidly we can change. That means we means humanity, human being. How rapidly human being can change our planetary environment for the worse. This is a clear-cut classical example. This lesson is not really being taken serious enough by the politicians. Climate change is a bigger problem to be fair. So these are the activities. Now urbanization, what you call, is very rapid nowadays, and all villages are being, what you call, urbanization is like a ghost which is expanding its tentacles into nearby suburban area and rural area, and swallowing villages, rural areas, and everything is being urbanized. So that's the problem. Industrialization, and we want to, what you call, more comforts, for power and energy, resource and everything. Industrialization is very rampant everywhere across the globe, and modernization, luxury lifestyle, and all this modernization, telecommunication, person to person communication, remote command to machine and robot function, and globalization. So we open doors, what you call, to the entire world. So anybody can go to any part of the world. Anybody can, what you call, hire or borrow technology from any part of the world in no time. So that means this process is creating a lot of pollution. In that process, what you call, we are producing so many chemicals which are detrimental for ozone, for the sustainability of the ozone layer in the stratosphere. Global warming phenomenon is the collective effort of greenhouse gases. All these greenhouse gases are given at the bottom of the slide. Global warming is linked to everyday habits and practices of billions of people of this planet Earth. Modern way of living and pursuing a livelihood are linked with emissions of CO2. Though it is not possible, though it is not possible to live in this planet without harming it, but it needs a systematic observation of rules of change, formulation of sustainable way of living, and leading life accordingly. So that is what is required. So we need to use resources, but economic utilization and rational utilization of resources, that is very important. Climate change is the offspring of global warming. The various global level environmental problems are the babies of climate change. So the basis for these sequential events up to now, greenhouse gases, greenhouse effect, global warming, climate change, ozone layer depletion. So it's all up to now is high carbon growth, high carbon economy, which is largely based on fossil fuels, which is largely based on non-renewable energy resources, consumption-oriented lifestyle. People are now across the globe, people are practicing consumerism as a religion. So eating, swallowing, enjoying luxury, these are the problems, consumption-oriented lifestyles. So this is creating all this nonsense. So now we need to switch from high carbon growth or economy to low carbon economy, instead of depending on non-renewable resources to produce a lot of pollution, to depend largely on a low carbon economy where there is no question of pollution. Renewable energy resources. Renewable energy resources are nothing but they speak about low carbon economy. Policies are needed to improve energy efficiency standards. Where people set tariffs for generating power from renewable energy resources, and also end subsidies for the use of fossil fuels. That is also very important. Decarbonization of electricity supply. Decarbonization, that means promote renewable energy resources and reduce the use of fossil fuels, coal or petroleum or natural gas, or what you call coal bed methane gas, or gas hydrates, tar sand deposits, what you call, and also so many other resources which are part and parcel of fossil fuel. We need to reduce those things and decarbonization of the electricity supply. It is necessary and fundamental to progress in other sectors, especially ground transport and domestic buildings. Postponing the need for new electricity generation capacity Here, cost-effective technologies are very important. Cost-effective technologies and also efficient technologies to use minimum use of what you call raw material to get maximum energy, for which we need effective technologies. At the same time, cost-effective technologies. That is also another point. Safe and secure disposal of nuclear waste, renewable energy, all these things we need to promote, renewable energy things, so you can read out. In agriculture sector also, new methods for food and non-food production and animal husbandry need to be developed and adopted to reduce greenhouse gas emissions. So we need to find ways and means to produce food by minimizing use of fuels which contribute to greenhouse gas emissions. Now, without controlling a population, it is not possible to control the greenhouse gas emissions effectively. Population control is very important. So, but nobody is concentrating on how to control population. That is a point in India. So India should concentrate more on how to control population. Without controlling population, it is simply not possible to control the greenhouse gas emissions effectively. So if more population, more use of resources, and more use of resources, more pollution. More pollution means more production of waste and sanitation conditions. So life becomes miserable. So that's the point. The population of the earth is increasing steadily, and it is easily understandable that for more people means more energy and more living space are a must, that imply more fossil fuel burning and more clearing of natural resources, say for example forests. Luxury is the major culprit that contributes most to aggravate the climate change situation, which is indirectly affecting the stratosphere. Due to our luxurious lifestyles, we are doing more things than what we actually need. Doing unnecessary things imply more energy use that generate more heat and CO2 in the atmosphere. Thus, we need to shun this useless extravagance. And lastly, love for idleness and less physical work made people more dependent on machines that are run by fossil fuels or use energy derived from fossil fuel. This is the point. So people are depending mostly on machines. So people are not doing work. Even households, they are not doing physical work. So they are simply putting the button, and they are getting the work done. So we are largely dependent or maybe exclusively dependent on machines. It has become people's habit to get simple works done by various machines instead of doing it manually. So that is where at individual level, we can take decisions how we can do a lot of physical work for doing certain works, so that we can avoid using certain machines and also using power for running those machines as well. But only changing this habit can help a lot towards achieving a low carbon economy, which is ultimately which is beneficial and advantageous for the protection of ozone layer in the stratosphere. If finally ozone layer is not there, and if ozone layer gradually gets depleted and the hole gets expanded, then now. And some scientists have what you call in some parts of the globe, if life disappears, so then for future use, wherever life exists, wherever human beings or populations exist, for future use, some scientists have what you call deposited what you call crop seeds for future use, for doomsday. So in Bible there is an ark, Noah's ark, when a flood was there during Moses' time, and for 40 days and nights, and there was a flood, and only one ark was simply floating on that flood waters. And in the same way, scientists have deposited the seed vault in this particular, it is a secure seed bank on the Norwegian island of Spitsbergen near this Longyear Bay in the remote Arctic Svalbard archipelago, about 1,300 kilometers from the North Pole. Conservationist Carrie Fowler, in association with this consultative group on IAR, International Agricultural Research, started this seed vault to preserve a wide variety of plant seeds that are duplicate samples or spare copies of seeds held in gene banks worldwide. So they have collected genes, germplasm worldwide, and they have put all these things in this seed vault. The seed vault is an attempt to ensure against the loss of seeds in other gene banks during large-scale regional or global crisis. Seed bank is 120 meters inside a sandstone mountain on Spitsbergen Island and employs robust security systems. They are packaged in different foil packets, and this is about, and also this particular area where the seed vault is placed, it is very ideal because it lacked tectonic activity and had permafrost, which aids perfect preservation, which doesn't require any power. So it's a permafrost frost region. That's why they have identified that particular area, mountain, to vertical, to keep this seed vault inside. So this is how they have deposited the seed vault. So they need not monitor, cooling temperatures and all, because it's a permafrost region. So for future use, so scientists at UN level, they are also taking care of this. If something goes wrong at the global level, food crisis, what you call seed crisis, whatever. So for future use also, they are taking measures for the protection of seed bank in this way. So finally, I am closing my talk. Change in lifestyles very essential. Simplicity is very important, not complexity of lifestyle, and reduce resources consumption, reuse resources, recycle used resources. So save planet Earth, we must act now, or it will be too late to tackle the demise of this only known fountain of life in the universe, because there is no life on other planets as of. So that is according to our knowledge, the life exists only on this planet. Maybe microorganisms are there on other planets, but macro life exists only on this planet. Controlling population and lifestyle, adapting to the natural processes. Lifestyle adapting to the natural processes are principles for marching toward our destination of low carbon economy, for a blissful and happy living on this globe, in order to prevent man or woman or human made disasters. So with this, I close my talk. Thank you very much for listening to my talk. Hello. Hello.
Sir, am I audible?
Yes, I have
Yes,
finished
sir.
my talk.
Yes, sir. Yeah. Thank you, sir, for a brief note on ozone and global warming. It is quite informative session. So just moving on to the questions from apart from your presentation, sir. So the first question is why has an ozone hole appeared over Antarctica when ozone depleting substances are present throughout the stratosphere?
Repeat your question.
Yes, sir. So please stop sharing your presentation, sir.
Just 1 minute. Yes.
Yes, sir. Shall I repeat the question, sir?
Yeah.
Yes, sir. Why has an ozone hole appeared over Antarctica when ozone depleting substances are present throughout the stratosphere?
Throughout the stratosphere.
Yes, sir.
Throughout the stratosphere, hole is not there. That's what you are talking. Huh?
Yes, sir. Yes, sir.
So that is where this meteorological conditions. Here, meteorological conditions matter for the creation and for the closing of that particular layer or thinning of ozone layer.
Okay, sir. Moving on to the second question. Does depletion of ozone layer increase ground level ultraviolet radiation, sir?
Ground level.
Yes, sir. Ground level ultraviolet radiation.
Ground level ultraviolet radiation it can absorb, but it is not in vertical. It is in a vertical in a scattered form at ground level, right?
Okay, sir. Okay, sir. Like when a depletion of ozone layer increases, so how it affects on ground level ultraviolet radiation, sir?
Ultraviolet radiation, if it is if it is UVB, it will absorb. If it is UVA, it won't absorb.
Okay, sir. Thank you so much, sir, for answering the questions.
Yeah,
Thank you so much for joining the webinar session apart from your busy schedule. Thank you, sir.
yeah.
Now, moving on.
Yeah,
Yes, sir.
Bhanu Kumar sir is there, and he will give you all the details.
Yes, sir. Yes, sir. Now, moving on to the second speaker presentation. Now I request Shri S. Bhanu Kumar, Professor of Meteorology, Honorable Director of Department of Yoga and Consciousness, Andhra University, Visakhapatnam, to please present your presentation, sir. ఏంటి అంత తీసుకుని వస్తుంది
Hello. Hello. Hello.
Sir, yes, sir.
Am I audible, madam?
Sir, you are audible, sir.
Am I audible?
Yes, sir, you are audible.
Okay, wonderful. Yes, yes.
Yes, sir, you can please
Let me
begin
greet.
your talk, sir.
Make a button. Yes. Let me greet all of you on the great occasion for all of us to take care of ozone, because ozone is for our entire life. So here, the very interesting day today is International Day of Preservation of Ozone Layer, and generally this will be celebrated every year on 16th September. This year, the theme is different, and we will discuss about the theme later. Just outline of my talk is layers of the atmosphere, various gases, history of ozone, location of ozone. Ozone means it is there both at surface as well as stratosphere. That means in the troposphere as well as stratosphere. And how you measure the ozone by using in situ data as well as by using remote sensing data, that is by using satellites. Then how ozone layer is depleting. Suppose if it depleted, what are the repercussions? Similarly, we have a lot of research about ozone hole or the Antarctica, and we have visited about the Antarctica Center at Goa, and they have a lot of data sets also. And why Antarctica only this type of problem? And some questions were asked about the same. For that, I will explain you why we have this problem, especially for the Antarctica. And over other parts of also, we have a lot of depletion of ozone is taking place. For that, we have our own explanation and what type of preservations we have to take. So if you want to really protect our Mother Earth, the first and foremost thing before global warming is protection of ozone. If ozone is depleted, I think it is more serious and more severe problem than the global warming. Global warming effects are really are not that much problematic when compared with the ozone. So world ozone and how to protect it is our everyday business, and every day we have to think seriously. So, based on the importance of this thing, United Nations International Day for the preservation of ozone, they have celebrated fixed a day that is about 16th September every year, with changing different themes. So every year, depending upon the lapses which we made in the last previous years, we keep updating our models, as well as we are updating our day-to-day information to make use for the public. And this event has really started in 1987 in a bigger way, with in association with the Montreal Protocol. So this is the very good beginning day. Though it was invented about 117 years back, it came into light the existence and very importance of this thing is only in the Montreal Protocol. And so since 1987, it is a very important thing that all over the world they have come to a conclusion that it should be protected, and sufficient information should be given to the public, and feedback should be also taken to protect these things. So especially this Vienna Convention, really 35 years back, since onwards, that means 87 to 2022, if you take 35 years, this convention is really working very well. And Vienna Convention went effect 88 as well as 2009. So all these are very important things as far as history is concerned. So coming to ozone, as a meteorologist, I will say that we have troposphere as well as stratosphere. And we have other spheres also, mesosphere, thermosphere, exosphere, but we are least bothered about those things as far as ozone is concerned. So we have ozone not only in the troposphere, but in the stratosphere. So in the troposphere, we have ozone, which is very, very dangerous, which affect immediately. In the stratosphere, we have ozone, which will help to filter out all the ultraviolet rays and save us. So if we take in the troposphere, we have weather, we have rain, we have so many atmospheric phenomena take place, and this height is about 14 to 16 kilometers height, and important weather conditions are there. So if you come to the stratosphere, here we have opposite. Temperature increases with height, and it absorbs most of the damaging ultraviolet sunlight. That is the great part. That is where all human beings are comfortable as far as Earth is concerned. So if you so enter the globe, enter the different galaxies, we never find another Mother Earth for the livelihood of our people. So that's why there is a bound and duty for us to safeguard the Earth under all circumstances. So now let us focus our attention about what is happening there, what is the role of troposphere, and how ozone is generating, and how ozone is coming in the stratosphere with the high temperatures. So you know that important gases in the atmosphere, nitrogen, oxygen, so on and so forth. But we have been putting our focus only on the ozone, which is about 0.07 parts per million. This is a hot, and this plays a very crucial. Don't be under the impression this is only 0.07 parts per million, but its role is highly remarkable when compared with the all other gases. I don't say all other gases are not important, but all other gases are, they are doing their role, but this is doing a special role when compared with the other gases. So this was invented by Christian, and let's say hats off to him for doing a thing. And my previous speaker, my friend Salman Raju, has already told who has invented all these things, so I don't want to spend much time upon it. And who has formulated about ozone, O3, is about the Louis. So all these things were covered by the previous speaker, so I don't want to put much time on these things. So our life would not be possible without sunlight. So ozone layer makes life as known it is possible. A gas composed of 3 atoms of oxygen, we can call it as a ozone. So bluish gas with a different smell. The total mass of ozone in the atmosphere is about 3 billion metric tons. This is a roughly estimated thing, so that we have an idea. It is just like a ribbon. I will show you on another pictures. So the peak concentration of ozone occurs at an altitude of roughly 32 kilometers. So that is a very, very important height we have to there, and we should not try to disturb that 32 kilometer height as far as possible. But only atmosphere can do it. So if you come to focus your attention on this, 90% of the ozone is in the stratosphere. It is a very good ozone which helps for the human beings. So ozone in the stratosphere is wonderful. It is just like a blessing for all of us to escape from the clutches of so many diseases, cancer diseases. So we have about 90% of the ozone is concentrated in the stratosphere, while only 10% of the ozone is in the troposphere. It is because of the man-made errors, because man-made luxurious things. So this 10% is more dangerous for us, and 90% is doing really very good job for us. If you see groundwater ozone formation, the following probabilities are like that. First one is secondary pollutants. Next one is VOCs plus NOx that results in ozone, and the presence of sunlight. Ozone plus NOx plus HCF, they are creating like a smoke plus smog. This smog is also creating some sort of ozonic information, which really matters. So if you see the sources of ozone over the surface, the following. So who made this thing? Our cars, our industries, and our electricity. All these things really making a smog, which really make us discomfort and which really affect our lungs. So our lungs are easily disturbed and very many lung diseases, especially people of very, very old age and people of very young age, they are highly affected with these things. So these are some of the other volatile organic carbons from the car as well as from the other sources, the industrial sources. We are getting this type of tropospheric uh, ozone, and these are also other reasons for which you are going to get a tropospheric ozone. So for this, how can we arrest this ozone? Yes, if you are really have some sort of interest to avoid the problems of bronchitis and all other things, we have to have our things. That is about keep your automobile well tuned and maintained. That's why every 2 years or every 1 year, everybody should make out your vehicle, car or two-wheel, all the things. So they should be checked and what are the outlets and what are the things to be done to avoid the wastes or gases that are coming out. That's very, very important. Similarly, as far as possible, government should put the general transport much cheaper. Then many people like to go on a common transport, and that will be very, very helpful so that we can reduce, or you can have a carpool and try to go in a very easier way with less risk. Similarly, we can have a spill of gasoline that will also making a lot of impact. And when filling up your car, gasoline powered lawn and garden equipment, they should also give. So try to see that during the summer, fill your gas tank during the cool time, that is early hours, than in the evening hours. Like this, you can avoid some of these things. So it is interesting to know that the ozone depletion discovered, and the ozone invention, though was done in 1913, the depletion was done in recent times, and that made a really lot of sick for majority of the people, especially Antarctic. And for this Antarctic hole, meteorology plays a very, very important role, and that also I will explain you. So this is the way how stratospheric ozone is forming, and this stratospheric ozoning, as I told you, is 90% of the stratosphere, and ozone absorbs band of ultraviolet. That is the great job done by the upper stratospheric ozone. If it has been not done, we would have been suffered with cancers, and this much amount of population would not have been stayed by today's. So this is just like a guard for us to safeguard from the ultraviolet rays. Then next important thing is how we are able to measure the satellite with the help of satellites as well as with the help of in situ data. We can measure, we can estimate. So we have satellites, we have balloons, we have about low latitude aircrafts, laser beams, as well as ground based systems, as well as high altitude aircrafts. All these things are there to measure upper air ozone concentration both in the northern hemisphere and southern hemisphere. So the first instruments for routinely monitoring total zone is Gordon Dobson. he is from UK. He is the first man who is able to measure this thing. So this is a wonderful job. So these things, these measurements techniques can be done both as well as local and remote sensing. So in Andhra University, in the Department of Meteorology and Oceanography, we have ozone data, and this data is collected by microtop to um, ozonometer. So we have a lot of data, and we collect only in the tropospheric data sets. Similarly, this European METSAT as well as and METOP A and B satellites are measuring global ozone concentration in the stratosphere by using a instrument, GOM2 instrument. So ozone in the atmosphere can be measured in a scientific fashion. We can have a very, very correct value. This is one of the achievements done by our scientists to assess very, very correctly about the ozone in the stratosphere. On an average, ozone in the atmosphere is about 300 Dobson units. So this is a standard measure we have to do. When it comes to less than 250, we will say ozone depletion. So if it is around 300 Dobson units, that's good. So we are safe from the ultraviolet rays. So generally, this ozone depletion takes place. That means whenever you have a reduced by 350 to 250 or 240, we will say it is a nothing but ozone depletion. So this ozone depletion is done because of CFC, chlorofluorocarbons, hydrofluorocarbons, halons, methyl bromide, carbon tetrachloride, methyl chloroformate. These are the things that will play a very important role to disturb or to mitigate or to reduce the thickness of the things. So this ozone depletion process, this ultraviolet rays, whenever you have a thick cloud, 3, 1 and 3, you will see that you have a thick ozone cloud, and where it is filtered, where it is not good, there you have a UV radiation. So the impact of UV radiation depends upon only on the ozone thickness. So generally, various sources are there that harm the protective ozone layer, mainly solvent cleaning products. They are the more dangerous. They contribute about 36%. And next important thing is refrigerator and air conditioner are about 30%. These two are the major dangerous things to make some effect on the ozone. The effects of ozone is about skin cancer, premature aging of the skin, and other skin problems. Cataracts and other eye damage will be also there because of the ozone. So, if you ultraviolet rays put on us, so immune system also suppressed with the impact of ultraviolet rays. So ultraviolet rays are our first enemies. Every day, every time, every minute, every second, we are facing, unless and until your ozone layer is not maintained profoundly. So, first research about the ozone hole was done by Susan Solomons in 1986. So, that was a big beginning. That is a great research as far as expedition to Antarctica identified the area where, why lot of because if you take Antarctica, there the population is much. So population is not making any sort of this hole. But other important factors are there. What are the other important factors that you have to see it? So this is Antarctic ozone hole that is about in 2000, that is detected from the satellite pictures. The area having less than 220 Dobson units of the ozone in the overhead column is treated as a Antarctic hole. So this is a picture that is about ozone hole that has formed here. So why Antarctica only this problem? That's a good question. Last time also asked. So ozone holes have a unique regionality and seasonality. That means they are highly variable on space and time scales. So in which season, which it has in different seasons, it has a different concentrations and different ways. They are very high over the middle latitudes in both the hemispheres and relatively less over the uh, tropics and other regions. It is most severe over Antarctica in southern hemisphere, especially during September and October. This is because of a meteorological reason. What meteorological reason? I will tell you. Specific conditions that make ozone depletion most severe over polar region or Antarctica are here you have a unique circumpolar circulation pattern over Antarctica is there. So as you can see the picture and you will enjoy about the cold air. This is the cold air which disturbs the ozone pattern, makes a much alarming thing. There are some years in which it has came down to 86 figure also from 300. So that means it is a very, very alarming. So isolates the stratospheric inside a vortex, acts like a container in vessel. That's why it is going to disturb that particular height, the stratospheric ozone. Here, a lot of chemical reactions may occur in near isolation, and whatever the population is there, they will be highly affected. The presence of polar stratospheric ice clouds play a very, very important role. On the surface of these extreme cold conditions, particles, certain chemical reactions are more effective and faster in that particular region, and it is going to disturb the stratospheric ozone concentration. So you can see the how it is. Those arrows will give you a wonderful, clear picture about how it will be taking place. This is the intensity of ozone depletion varies from year to year. So it keeps on changing from year to year, depends upon the different circumstances. So not only human beings are making some sort of disturbance to the ozone, at the same time atmosphere circulations in the stratosphere also plays a very important role as far as these things are concerned. So in 1 year, very astonishingly, 2006, we had only 85 Dobson units that is ever recorded by a satellite measurement. So this is the least amount of ozone we have uh, so far. What about the parts of the globe? So not only the this Antarctica is affected, but if you compared northern hemisphere as well as southern hemisphere, in the southern hemisphere we have a depletion about 1.1 to 9%, whereas in the northern hemisphere its depletion is about 1.1 to 3.7. Why in the northern hemisphere we have up to 3.7? Because more population is there. China and India are there along with the other nations. So where populations are there, where we have a lot of disturbance about the ozone, especially middle latitude zones have been decreasing by about 4% because of different reasons. So where tropical ozone has been remained more or less constant. So we are happy. So all the people who are staying on either side of the equator, which we can define as a tropics, there the effect of ozone is relatively very, very negligible. But don't be under the impression we have to disturb it. So similarly, if you have the depletion in future also, what we have to do? So at home air conditions, refrigerators which generate CFCs, we have to have correct. I mean that means today, if you go to the market, 5 stars are there. If you purchase AC or if you purchase a refrigerator, he will show you all. If you purchase any electrical bulbs or electrical lights, he will show, sir, you want 2-star, 3-star, 4-star, 5-star, like that. So all the time we have to prefer only the 5-star. Or government make it mandatory to sell only the 5-star things, so that we will never disturb the ozone layer. Similarly, car and home air conditions, car air conditions as well as home air conditions, they are also making a lot of nuisance or a lot of disturbance, this thing. So they should be checked, and they should be also checked any leaks, and see that they will be high rated things should be purchased, so that they won't release much of the damaging things. So repair leak air conditions units before refilling them. You should be careful in making use of the liquid. Similarly, what type of protection yourself against sunburn is about minimize sun exposure during midday hours. So if you want to do it in the early hours, or do it in the evening times, so that will be better. Similarly, try to wear glasses, and try to wear hat, which will be helpful to you, and protect your body with tight waves tight wave tight shirts or bunions. Or sometimes if we have disturbed, we have to wear suits which will not allow you ultraviolet rays. Suppose if you disturb stratospheric ozone, then we have to think, you have to wear the suit which will not allow ultraviolet rays. So this type of suits will be also coming soon if you disturb the ultraviolet rays. Use a broad spectrum sunscreen with sun, so that you will not be affected much about. So especially in the middle latitude region where its disturbance is more, they will make use, and for the entire summer season, this protection for the sunscreen protection whenever they go outside. So this is a very very important point that you have to take if you want to escape from the ultraviolet rays. So, like this, if you protect yourself, if you want to really protect yourself, first don't disturb stratospheric ozone. So, if stratospheric ozone is not disturbed, so entire public will be safe. So, save ozone and save Earth. So, World Ozone Day is a great day for all of us, and we have to follow the footpath given by our scientists to safeguard the ozone all over the globe. So, this year, Montreal 35 is given, at the rate of 35 is given, because we have already completed from 86 onwards, we have completed about 35 years successfully. We are able to protect uh, stratospheric ozone, but we may not be that good in reducing tropospheric ozone. So, like this, if you continue and if you safeguard. Another interesting thing is, during the COVID period, these North Pole as well as South Pole as well as the ozone layers. This is about thickness of 3 millimeters. This ozone, though it is very important, if you consider its thickness, it is about 3 millimeters. That is really silly, but it is able to cut short, or it is able to stop all the ultraviolet rays. So this ozone is really great, and a lot of research is still going on how better we can maintain it, and how these flights and other things are really affecting, we don't know. Some research is going on in this direction also. So this is more dangerous than the global warming and climate change. So try to take care of and take all measurements to restore, or if it is disturbed, or try to protect our stratospheric ozone intact, so that it is just like a god for us, and it blesses us with a good health to escape from the ultraviolet rays. Thank you so much.
Thank you, sir. Thank you, sir, for a brief note on ozone and its importance and its prevention of depletion of layer. Thank you, sir, for presenting the slides in short period of time. Now, moving on to questions, sir. So, the first question
Please.
is, yes, sir. So, how do emissions of halogen source gases lead to stratosphere ozone depletion?
Yeah, this is a chemical reaction, and if you are good at chemistry, you will know that reaction. And in that reaction, it is a exothermic reaction, I guess. And I am also not a chemist, so I am a meteorologist. So these chemical reactions really make a lot of disturbance in its existence.
Okay, sir, thank you. Moving on to the second question. Do changes in the sun and volcanic eruption affect the layer?
Yeah, is this volcanic erection generates a lot of sulfur dioxide. So this sulfur dioxide is mixing with other gases, and they will disturb this uh, stratospheric ozone, as well as it gives a lot of tropospheric ozone too.
Okay, sir. So, with this, we end up with your session, sir. Thank you so much for joining the session and also clarifying the answer. Thank you, sir. Now, moving on to the third speaker. Now, I would like to welcome Ms. Mahima T, Senior Environmental Engineer, Central Pollution from Central Pollution Control Board of India. A brief introduction about ma'am. So, ma'am is currently working as Senior Environmental uh, Engineer at CPCB in Chennai, coordinated with activities of Andhra Pradesh for around 10 years. She'll speak us today on ozone depletion and actions required. Over to you, ma'am, to please begin your talk. I'll start. Ma'am, are you presenting or shall I present it?
No, you start sharing, Divya.
Okay.
Thank you so much. Good afternoon, everyone. Divya, can you start presenting? So before I just get into the topic of what is ozone day and all, first let us understand the atmosphere. So our atmosphere is nothing but a mixture of gases. So when we say layers, based on the type of gases present and all, and the variation.
Excuse me, ma'am. Sorry to interrupt you, ma'am. Just a second, ma'am. We are putting your presentation on full screen mode. Just a second, ma'am. Sorry to interrupt you.
Sure.
Yes, ma'am. Okay, you can continue, ma'am.
Yeah. Go to the next slide. Yeah. The atmosphere is nothing but a mixture of gases that is surrounding our planet. So once we say there are different layers in the atmosphere, there is no slideshow. Divya, I guess there is some issue. Divya?
Yes, ma'am. Just a second.
Yeah, sure.
Yes, ma'am, you can continue, ma'am.
Yeah. So once we say there are different layers in the atmosphere, based on the gases present, since the atmosphere is nothing but a mixture of gases, and the different conditions that are prevailing in each layer, the layers are divided. So the first of starting from the just above the Earth's surface up to around 50 kilometers, it is the troposphere. Above the troposphere is the stratosphere. So in the troposphere, we have like nitrogen is the largest gas, while in the stratosphere we have got the ozone. So if ozone is present somewhere in the troposphere or anywhere in the ambient environment, ozone is a pollutant. But whatever ozone that is present in the stratosphere is extremely essential for the life to exist on Earth. That ozone, the stratospheric ozone, is the one that is protecting all the harmful UV radiations that is coming to the Earth's surface. So once we say layers, it forms like it is surrounding the Earth in the form of rings, and it extends to about few hundreds of kilometers above the Earth. So oxygen, it occurs in three different forms in the atmosphere. One is as the nascent oxygen atoms. One is the oxygen molecule O2, which is more stable, and the third one is in the form of ozone. Ozone, exactly what I told. So we should not mistake the stratospheric ozone to the ambient ozone. If due to pollution, if in the ambient environment ozone is released, it is definitely a pollutant and it is harmful to us. But whatever it is present in the stratosphere, it is extremely essential for the life. And what is this ultraviolet rays means? The electromagnetic radiation and all that is coming from the sun, it is in a wide spectrum. So there is the visible light, there are the infrared radiation, the ultraviolet radiation also. The X-rays also is included. The ultraviolet radiation it comes next to the violet in the visible light spectrum. So why it's called as the ultraviolet. And in the ultraviolet radiation, it is again into three. It is classified into three groups. One is the UVA, UVB, and UVC. So UVA is the wavelength is between 320 to 400 nanometer. UVB wavelength is 280 to 320, and UVC is 200 to 280. The shorter the wavelength, it is more energetic and extremely dangerous. So the UVB and UVC, the wavelengths are short, but they're highly energetic. UVB radiation is prevented or controlled by the ozone, while UVC is protected by or absorbed by the oxygen. UVA is not so harmful, so part of UVA radiation reaches the Earth's surface also. So the stratospheric ozone, what it does is both UVB and UVC ultraviolet radiations are controlled or are absorbed. Next slide, please. So the ozone layer, it is nothing but a triatomic oxygen molecule. It's present in the stratosphere. It blocks all the harmful UVB radiation. So how do we measure the ozone layer? When we say ozone layer, we should not think it as like a thick metallic layer that is present. It is nothing but the oxygen or the ozone gas that is present in the stratosphere. Our concept should be the gaseous layer that is present, the gases that is present only. We should not think as there is a door or there is a blanket kind of a thing. And how do we measure this? The unit is the Dobson unit. So 100 Dobson unit is equal to 1 millimeter. So once we compress it under standard temperature and pressure, 100 Dobson unit, that is equivalent to 1 millimeter. Normally, the concentration of ozone in the stratosphere will be around 300 DU. If it reduces to less than 220 DU, it is called as an ozone hole. So, once we say ozone hole or there is a hole in Antarctica, people should not again mistake that literally there is no hole. But the depletion of the concentration of the ozone to less than 220 DU is considered as a ozone hole. It is only a depletion, not the complete absence of it. In India, Indian Meteorological Department is the nodal agency to measure the ozone levels in India. So next slide, please. So how it happens, how it protects, I'll just explain it. So naturally, this ozone in the stratosphere, it is naturally present. It's not something that the human made. So naturally, what happens? Whatever the ozone is present, it is present in balance with the oxygen, the nascent oxygen, and O3, the ozone. All three exist in a balance. The oxygen molecules, it will absorb UVC radiation and it will split into nascent oxygens, and the nascent oxygen again it will absorb UVB radiation, and it will connect to the ozone, and it will form it will connect to oxygen and it will form the ozone. So oxygen absorbs UVC, while the nascent oxygen it will absorb the UVB and forms the ozone. So the formation and depletion or the destruction is continuously taking place. So for this formation and destruction, once the formation and destruction, they are utilizing the ultraviolet radiation. But what happens is the once the pollution is there, what happens is we have got the CF is the chlorofluorocarbons, carbon tetrachloride, methyl chloroform or HCFCs and all. These are a very stable compounds. Once it was introduced in the world, it was thought as a miracle product, highly inert gases. So they release the nascent chlorine, bromine, fluorine into the atmosphere. They don't react in any particle in within the troposphere or within the Earth's surface. Since they are very stable and extremely inert, they rise up to the stratosphere. So here we need to understand the troposphere itself is extending up to 50 kilometers. Above the troposphere is the stratosphere. Since these compounds are highly inert, they are rising up to the stratosphere, and in the stratosphere, the chlorofluorocarbons are taking the ultraviolet radiation and splitting into a fluorine molecule. Again, the fluorine molecule, again it will absorb and again it forms the CFCs. So initially, what was naturally happening because of the uh, by absorption, the formation and the destruction was happening. Now, what is happening? The CFCs are disrupting the cycle, are interfering with the natural formation and the destruction. This is leading to the depletion of the ozone. So this is also combining with the naturally or the nascent oxygen. So CFC, when we say, it will not in the stratosphere, it will split into nascent fluorine, and the HCFCs will split into nascent fluorine and nascent fluorine and the nascent bromine. These are all disrupting or interfering with the natural formation. That's how the depletion is taking place. And one CFC molecule can destroy up to 1 lakh ozone molecules also. And since they are very stable, they can survive for a longer duration of time. So thereby, once the depletion takes place, so now obviously the UVB radiation that was prevented or absorbed is entering into the Earth's surface. So what are the impacts if we understand? The impacts are once the UVB radiation enters, so there will be sunburn, premature aging, damage to the eyes, skin cancer, reduced yield of the plants. There will be decrease in plankton and loss of biodiversity in the oceans. And also both, not just the UVB radiation, UVC radiation also will enter, which is mainly which mainly cancer causes the skin cancer. Next slide, please. So, how to uh, how to protect this, how to take action against this was a big question. So here we need to understand. We all understood that CFCs and all are the problems that it is caused due to CFCs and all. But where was this CFCs used was the question. Next slide, please. Yeah. So these are all the products that was used: the chlorofluorocarbons, carbon tetrachloride, methyl chloroform, hydrobromofluorocarbons, hydrochlorofluorocarbons, methyl bromide, and bromochloromethane. these are the 9 products, or these are the products that was used in India, specifically if I have to say used in India, that was causing or that was having the ozone depletion potential. And these were used in the shaving creams, or whatever we call the inhalers. In that it was used in the cooling sector, the refrigerants and all, it was used. Previous slide. In aerosols, or uh, uh, the deodorant and the perfume sprays what we use, in those sprays it was used. Paints and inhalers, fire extinguishers, it was used in all of these products. So as I told, India was using 9 of 96 substances that was having the ozone depleting potential. So around 1985, what happened? An Antarctica hole, or the hole in the Antarctica was identified. Scientists identified, like, there is a depletion, 40% depletion in ozone layer in the Antarctica, and it has to be addressed. After it was identified in 1985, it was observed, and in 1987, so the first this thing took place, and Montreal Vienna Convention took place, and then the Montreal Protocol was signed. It was signed on 16th September 1987. To commemorate that day, 16th September is been celebrated as the World Ozone Day. Under the Montreal Protocol, it is all the substances that are having ozone depletion potential are banned, and 198 countries have signed for, have ratified for it, and India is one of the nation that has signed to it. India has agreed to for the complete phase off of the ozone depleting substances by 2030. Next slide, please. Next slide. So the production and import of these chemicals is controlled by the Montreal Protocol. Next slide. So as I told, the Montreal Protocol is nothing but an international treaty to prevent to stop the substances, or to ban the substances that deplete the ozone layer. And since every year from 1995 onwards, we are celebrating this. And since 16 September was taken, because on 16 September 1987, Montreal Protocol treaty was signed. So since then, every year it is celebrated. And for this year, the theme is Global Cooperation Protecting Life on Earth. So, since I told you it is nothing but a gas, and a gas is not constant, it does not remain fixed at one place, it keeps moving. So, if one country says that I'll not sign the agreement, and it starts producing all the gases that deplete the ozone layer, there are more chances that the gases would just move around to the other places as well. So, in this connection, what they made is the global cooperation. All the countries have to stop using these substances to prevent the ozone depletion and to protect life on Earth. Not just, it is not a localized phenomena. No, now ozone depletion or greenhouse effect and the greenhouse effect and global warming, it's not a localized effect. It is a global phenomenon. So everyone has to participate in it. With that contention, it is made as a global cooperation, since so that all the countries can participate it. Next slide. Next slide. Yeah. And where do we stand? Implementation of Montreal Protocol in India. As I told, India has ratified to the Montreal Protocol, and India is a party to both Vienna Convention for protection of ozone layer and as well as the Montreal Protocol. So it is taken up to phase out the CFC, CTC, CFC, carbon fluorocarbons, carbon tetrachloride, halogens as of 1/1/2010, except for pharma grade. And India has achieved in phasing out. The success story lies here. India has achieved in phasing out the CFCs by 2010, now only in the pharma grade, after 2010, only in the essential pharma industry only it was used up. In the second phase, now phase out of production and consumption of methyl chloroform and methyl bromide also was done. India is successfully implementing the phase out program. Now we are in the advanced, the next level phase out program where the hydrochlorofluorocarbons we have taken up. So India has met with 2015 and 2020 targets, and the next is the accelerated phase out program, wherein to phase out 35% reduction of the hydrochlorofluorocarbons by 1/1/2020 and 67.5 reduction by 1/1/2021 and 100% reduction by 2030. As of now, we have achieved the 35% target and 67.5% target. Now we are moving towards the 100% reduction of HCFCs by 2030. So this we need to understand. This is a success story of India, wherein the ozone cell was immediately established in the Ministry of Environment and Forest, and all the industrial sectors that was producing the chlorofluorocarbons as a refrigerant, they were directed to stop the use of CFCs, and it was fully replaced, and alternatives were provided, and we were able to phase out. Next slide. So I'll just explain about what were the alternatives used. In the domestic refrigerants, in place of CFC 11, 12 and HCFC 22, it was replaced with zero ODP, that is zero ozone depleting potential and low greenhouse potential substances like hydrocarbon blend and ammonia was specifically replaced. And in the foam sector, it was replaced with methyl chloride and water-blown technology, hydrocarbons and carbon dioxide. In the solvent sector, it was went to the water or the aqueous cleaning process. Organic non-halogenated solvents was used. So the success story is not just how to phase out. To phase out, we need to have an alternative. The refrigerants, the refrigeration cannot be stopped. With the refrigerants, we started finding the alternatives, and it was successfully replaced. Today, if we go to the market, we are getting all the air conditioning systems, which clearly indicates what is the ozone depleting potential, whether it is 0 ODP or whether it is 3 ODP, 10 ODP, like this. In all the 5-star rating, it is always 0 ODP. If you go for a 3-star rating, it will have a lesser ODP. But preferably go with a 5-star rating which offers 0 ODP, that is also 0 ozone depleting potential, and also low greenhouse potential. So, and even with the low ozone depleting potential also, CFCs has been replaced with the hydrochlorofluorocarbons. So India's success story lies in this, where all the replacements were found in time and we were able to phase out. Next slide, please. And the production and the consumption control schedule as per the Montreal Protocol is, for chlorofluorocarbon, as we can see, 100% reduction by 2010, which India has achieved. And for halogen also, it was by 2010, we have to achieve 100%. That also India has achieved. And for carbon tetrachloride, by 2010, we have achieved 100%. And for MCF, we have achieved 70%. And by 2015, we achieved 100%. And methyl bromide, by 2015, we have achieved 100%. And hydrochlorofluorocarbon also, we have achieved 10%. So now we are moving towards the 2030 target itself, which India is likely to achieve. Next slide. So thank you so much. This is the India success story, and also the collectively all the people have joined in the collective efforts, so that we could prevent the ozone layer. We could protect the ozone layer. Let's all build a consciousness and protect the ozone. Thank you.
Thank you, ma'am. Is my voice audible?
Yeah, you're audible, Divya.
Yes, ma'am. Thank you so much, ma'am, for giving a brief information on ozone along with monetary protocol. And moving on to the questions. So the first question is, how is ozone expected to change in the coming decades?
How is ozone expected to change in the coming decades? Ozone, it's since the life is formed on Earth, it is ozone is present in the stratosphere, and we expect that it continues to remain in the stratosphere as long as the life exists. Only the troposphere ozone is very different. Troposphere ozone is a pollutant that is released due to the pollution, so that is formed in the atmosphere and all, in the troposphere or in the ambient environment due to pollution. So that should be controlled. But the stratosphere ozone, we all hope that it should remain as long as life exists. Any other questions, Divya?
Yes, ma'am. The
Yeah.
second question is, what are the principal steps in stratosphere ozone depletion caused by the human activities?
Yeah, yeah. As I told you, the chlorofluorocarbons and all the chlorine molecules, the bromine molecules, and the fluorine molecules are the molecules responsible for the disruption. And these was used previously in the shaving creams, in the perfume bottles, the inhalers, and all what we use. All whenever we need a spray form, this was being
Yes.
used. And the asthma patients, they use the inhalers. It was used in that. In the cooling sectors, it was used in the solvent, in the industries, especially where all the pharmaceutical industry for cleaning, solvent cleaning, it was used. So, since I told you, since it's being extremely stable and inert, it was going up to the stratosphere. Now it has been completely, the CFC has been completely replaced in India.
Okay, ma'am. Thank you, ma'am, for
Thank
joining the
you.
session. I thank all the speakers for joining the session, ma'am. Thank you.
Thank you. Can we leave now?
Yes, ma'am. Yes, ma'am. Sure. Thank you so much for joining the session. Thank you.